Hi, it's David Shummy again from foamboards.com.au. We're just going to show you how to do a three-dimensional architectural plan in this video. I hope you have fun making something like this. Today we're going to make a three-dimensional model of this house plan. It enables you to have a good look then where everything's positioned. We're going to be using foam core, which is a lightweight board or foam board, and also we're going to use a self-adhesive foam board where we have a sticky coating there. We've got several tools that we'll be using today, including just a basic everyday Stanley knife. We've got various tools from Foamworks which are fantastic. This is a freestyle cutter, rebate cutter, straight and bevel cutter that we use to do a lot of our trimming. Various drills of different sizes. These have quite sharp points, so we keep a little rubber cap on there so we don't hurt ourselves when we're not using them. We also have a circle cutter that we use to trim some of our circles, and there are various bits and pieces in the Foamworks range, like in the accessories kits that have joiners and pieces like that that we might be using. I like to use a couple of different tapes. I'm just using an ASAP framers tape here actually to do some of the hinging because it's nice and white. Foamworks also make a good frame tape that you can use to hinge your foam together. I'm using one of the blue painter's tapes because these are great for putting things together temporarily, and then you can peel it off without damaging the actual foam board. Also, I have some 6mm double-sided tape. This is fantastic for joining foam pieces together. We'll be using that today. I've got a little T-square that I use to square things up. That's very handy. And also, I like to use some stainless steel pins. These are just a dressmaker's pin, but they're quite handy when it comes to pinning foam board together, because you can use them to hold bits and pieces. Anyway, let's have a look at how we do it. The first thing I've done is I've designed my building as I like the look of it, and now I want to show the client what the thing will look like in 3 dimensions. So it's quite easy to either print the plan out onto paper, or if you're doing a project at home, you can just draw this straight onto the foam board itself. But because I've printed mine on paper and now I want to make it rigid, I'm going to be using this self-adhesive foam core, which I'm going to stick the plan onto. The way I stick the plan is I am going to line that up. I've trimmed the board to size so that it fits perfectly the size of my plan. I then peel back the adhesive part of the board, peel back the release paper, and I put a little fold in there. Then, being careful not to stick it, I get the piece in alignment. Once it's in alignment, I start in the center and I push that down onto the backing board. So now I'm going to stick it into place. From the middle, I work out to the edge. So now I have my board partly stuck on the edge of the adhesive board. Now, using another piece of foam core, I'm going to smooth that board down onto the board. Now that I've got the edge of my plan glued to the board, I'm going to use another piece of foam board, and this I'm going to smooth the plan down with. So I start by putting the board on top of the plan, and then I lift that over and get hold of the release film underneath. Then I gradually, by working along and pulling the board off,
I just keep pulling that release film and smoothing. I'll take all of that off now and smooth that plan down onto the board. So now I have a smooth plan ready to start building. The first thing to do is to measure up your foam core, and we've made this plan at a scale of 25:1. The height of our ceiling is going to be 2400 millimeters or 8 foot high. So when we work out on that 25:1 ratio, the actual width of our foam core for the height is 96 millimeters or 3 3/4 inches. What I'm going to do is I'm going to cut some strips 96 millimeters wide, which will represent the height of our walls. So I come in and mark my 96 mil or 3 3/4 inches, and then I put my ruler, and I'm using a Foamworks ruler here because it does have a distinct advantage. It has a rubber grip strip on the back which enables it to grab onto that foam core firmly so it doesn't slip around. Also, it's the length of a standard foam core board's width, so it's very easy to cut a board in half with this ruler. I'm going to align my ruler with the pencil marks, and then I'm going to use a Foamworks straight cutter to cut it. Okay, what I've got here is a Foamworks straight cutter. It has a spring-loaded head that enables you to move the blade up and down. We're going to have a quick look at how we put the blade in. These are a special blade that's designed to cut foam core well. The blade locks onto a registration pin, and then there's just a simple clip that fits over and locks that blade in place. So now we have a sharp blade ready to cut the foam core. The one good thing about using this tool to cut foam core is that this blade is at exactly the right angle to achieve a perfect result. We could just use a Stanley knife, but it requires some skill to get this both square to the shape that you want and to cut cleanly. So with a Stanley knife, it is always, of course, the flat bottom edge that does the cutting, not the tip. So remember, if you're using a Stanley knife, to have a shallow angle of attack when you cut the board. And as you can see, this already has the correct angle for achieving the best result. The other thing I like about this tool is on the bottom here we have an adjustment, and that's adjusted by the dial on the back. We can adjust this size to set the depth that our actual board cuts. So what I'm going to do is I'm going to wind this down because I'm using 3mm board in this case. So my little arrow in here, I'm going to set that to just on the 3mm. A little bit more than 3mm because I just want to cut through slightly. Now that will then set this blade to just the correct depth for cutting 3mm. If we were going to use 5mm or 10mm, we can just adjust that back to that size. The other good thing about this tool is it has a groove on here, and that groove locks on to the rail, so we always achieve a straight cut. So it's easy now using this to align my ruler, put my cutting tool ahead of the cut, and you can see this blade, it runs so close to the edge of the ruler there. It's perfect. You achieve a great result every time. Then I can apply gentle pressure, come in and cut through that board. Now I like to do it in 2 passes. so that I get a totally clean result. So I didn't give it a maximum pressure at that point, but now I'm going to put it all the way in. I creep along as I go so that my ruler doesn't move. Now what we've done there is we've cut our first piece exactly at the 3 3/4 inch mark, which will represent our 8-foot high ceiling, or 2400. We're going to repeat that process now and cut several pieces. So now I've got several pieces of board. They're all cut to the same width and height, ready to do my walls. What I've done is I've worked out a cutting list on my Excel spreadsheet. But if you were doing a plan at home, you can also work on a little piece of paper. So here, my study, I'm going to actually cut it 4070 in real life, and if I work it out at my 25:1 ratio, that equals 163 millimeters. Using my square, I'm just going to set that 163 millimeters, or I could use my ruler to measure it, but I find when I'm replicating things often, it helps to use this. I use the end of my square on the board, come along and make a small pencil mark. Then, with my square, I align that pencil mark and draw a line that I'm going to cut. Now I could cut this as a separate piece, but what I'm going to do is I'm going to use the Foamworks bevel cutter. So on the Foamworks bevel cutter, I'm just using the quick change function. This has 2 blades on this machine, one on one side and one on the other. So this is going to enable us to cut a V-groove. Also on the bottom of the machine we can adjust the thickness of our board. So I've set that to the 3mm thickness.